Welcome to another session in this series. In this session, we start with question number 57. In the previous session, we ended on question number 56. Okay, so in this session, we start with question number 57. Cool. The question says, if T is a set of prime numbers and M is a set of odd numbers, and this T and M are subsets of the universal set, which is S is said that 0 is less than X less than 10, okay? And X is an integer, then find T prime intersection M prime, okay? T complement intersection M complement. Cool. So first we need to find the prime numbers and then also the odd numbers, okay? But first let's write the what? The universal set. Let's write the universal set. The universal set is a set of numbers, integers from 0 to 10 with 0 non-inclusive because of the sign less than, okay? And then 10 is what? Inclusive because of this sign less than or equal to, okay? So let's write it. So that will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, cool. Now let's write M. Let's write M. No, let's write T first. Okay, T is what? Prime numbers. So we start from 2, 3, 5, 7. Now I stopped at 7 because the next prime number is what? 11. And 11 is not in this universal set. We have to make sure this T is a subset of the universal set as you have been told in the question, okay? Cool. Now let's move on to M. Let's move on to M. M is a set of odd numbers. So we start with 1, 3, 5, 7, 9. You need to stop at 9 because the next odd number is 11 and 11 is out of this set, but our sets need to be a subset, okay? So we stop here. All right, now we need to find T complement and M complement, and then we find the intersection. So intersection, okay, sorry. So now let's find T intersection. T complement. That will be what? Sets that are here but are not here, okay? So that's, what is that? So we have 1 here, 1 not here. So 1 comes here, okay? 1 comes here. Cool. And we have 2 here, 2 here, 3 here, 3 here, 4 here, 4 not here. So 4 comes here, okay? 4. Cool. 5 here, 5 here, okay? 6 here, 6 not here. So 6 comes here, okay? 6. And then 7 here, 7 here, 8 not here, 9 here, 9 not here, 10 here, 10 not here. So we have 8, 9, 10 in here. 8, 9, 10, okay? Let's write that. 8, 9, 10. Cool. Now let's do the same for M prime, M complement. Okay? So we have 1 here, 1 here, 2 here, 2 not here. So let's write 2. We have 3, 3, 4, 4 not here. Okay, so write 4. Okay, 4. Okay, 5 here, 5 here. Okay, 6 here, 6 not here. So you need to write 6 here. 6. Let's move on. 7 here, 7 here. Okay, 8 here, 8 not here. So 8 comes here. Okay, I have 8. Okay. Let's move on. We have 9 here, 9 here, 10 here, 10 not here. So 10 comes here, okay? We have 10. Cool. So now we are done with that. So now we need to find the intersection. That is the element that are common to this and this, because that's what we need to find, right? So which elements are common? 1 here, 1 not here, okay? So let's open the solution set, okay? 1 here, 1 not here, so it's not common. 4 is common. 6 is common, 8 is common, and 10 is common. So we have 4, 6, 8, 10. Okay? 4, 6, 8, 10. That is our answer. Do you have it there? Yes, which is D. D is our answer. Cool. Let's move on to question number 58. The question says, if P is equal to the set S is said that negative 2 less than X less than or equal to 3, and Q is equal to S is said that 0 is less than or equal to X less than 5, and then there are subset of this, which is negative 2 less than X less than or equal to X less than or equal to 5. Find P complement union Q. Okay, so let's write P and Q down, and also the universal set. Okay, cool. So we have, where's the universal set? Yeah, the universal set to be what? Universal set is from negative 2 to 5, all inclusive, because we have less than or equal to. Okay, so negative 2 to positive 5. So we have negative 2, negative 1, 0, 1, 2, 3, 4, 5. Okay, now let's write down P. We have P is what? From negative 2 to positive 3, but the negative 2 is non-inclusive, okay, because of the sign. Okay, so we have, negative 1, 0, 1, 2, 3. Once we are at 8, let's just find P complement at the same time. So P complement will be what? Elements that are in here but not here. So what elements are that? We have negative 2 is not here, so we add negative 2 here. Okay, and then we have negative 1 and negative 1. Okay, 0, 0, 1, 1, 2, 2, 3, 3. Okay, but then we are left with 4 and 5, which is not here. So our set here will be what? Negative 2, 4, 5. Okay, negative 2, 4, 5. Okay, cool. Let's go back and then let's do Q. What is Q? Q is the set of integers from 0 to positive 5, and then the 5 is non-inclusive because of this sign. Okay, so let's write it down. We have 0, 1, 2, 3, 4. Cool. Now the question says you should find P complement union Q. Okay, what this means is this set and then this set together. Okay, this set and this set together. Cool. So let's write it down. That will be the set negative 2, then 0, 1, 2, 3, 4, 5. Okay, let's see. 0, negative 2 here, negative 2. Okay, 0, 0, 1, 1, 2, 2, 3, 3, 4, 4. Okay, and then 5. So this is our answer. This is our answer. All right, let's move on to the next set of questions. It says if the number of P is equal to 54, the number of Q is equal to 27, the number of P union Q is equal to 69, find the number of P intersection Q complement. Okay, so I think we have to postpone this to the next session because our time is getting longer. Right, see you in the next session. Bye.